We want to talk about transposing arrays and getting the dot product or the inner product of a matrix. So first of all, what does transpose amount to? Let's create a multidimensional array here. Just to remind us of what this reshape function does, we're defining a 3 by 5 matrix, and we're saying, okay, well, this is going to take 3 times 5 values, so we need to create a numerical range of 15 and reshape those 15 values into this 3 by 5 array. So let's do that, and we get a 3 by 5 matrix as expected. So what transpose amounts to is we're just rearranging these rows into columns and rearranging these columns now into rows. So where this is a 3 by 5 matrix, a transpose of that is going to be a 5 by 3. So let's see that in action. Indeed, we get a 5 by 3 matrix with the values transposed. So here's 0, 1, 2, 3, 4 in a row, which is 0, 1, 2, 3, 4 in a column. That's basically what transpose does. When is transpose useful? One way it's useful is if we wanted to get the inner product of a single matrix. Without getting too hairy into the math, let's talk about what the dot product amounts to. Let's create another array, a 6 by 3 matrix. That's going to require 18 elements. If we run that, and then we grab the transpose of that, we get a 3 by 6. To get the dot product, essentially we take this 6 by 3 matrix and we do matrix multiplication on it. So we multiply that by its transpose, which is a 3 by 6. And our answer is going to be a 3 by 3. And whenever we do matrix multiplication, these two numbers have to be the same, or we won't get a correct answer. So just to get our minds around what's happening here, if we have this 3 by 3 matrix over here, we'd like to define briefly what the computation involved is going to be. We can think of this as row 1, row 2, and row 3. And we can think of these columns as column 1, column 2, and column 3. And what we have to do is take row 1 times column 1 to get this value. Let me change this color so we can color code these. And what we're saying is we need to get row 1 times column 1 in order to get that first value. So 0 times 0 is 0. And we have to add the next one, which is 3 times 3. So we have to add 9. And we have to add the next one, which is 6 times 6, 36, plus 9 times 9, right? 9 times 9, which is 81. And 12 times 12, which is 144. And then we have to add 15 times 15, which I believe is 225. And if we add all these together, sum those up, that'll give us row 1 times column 1. That's one step in many, because next we have to multiply row 1 times column 2. And if we do that, we're going to get this value. And next we have to multiply row 1 times column 3, which will yield this value, row 1, column 3. Row 1, column 3. All right, well, we're just getting started for matrix multiplication, because in the next case we have to multiply row 2 by column 1 here, which is going to give us this value, and then multiply row 2 times column 2, which is going to give us this value, row 2 times column 3, which is going to give us this value, row 2, column 3. And finally, you might be able to predict what's coming. We need to multiply row 3 times column 1, which is going to give us this value. Row 3 times column 2, this value. Row 3 times column 3, this value. Row 3 times column 3 gives us this value. And that's a lot of computation. So we just use this dot method. we have to put the transpose of the dot array first and the dot array second in order to get the inner product of dot array. So let's run that and we'll get our calculation.